Aloha! In today's AstroBreak, I am going to tell you the most amazing fact. You and I are made of stardust. While it sounds like I'm being a little bit poetic, I assure you I am speaking entirely literally. When the universe first began some 13.8 billion years ago, there were only two elements on the periodic table in existence: hydrogen and helium. Fortunately, this is what stars are made of, and stars can make nearly everything else. Since the very first stars were born at the beginning of the universe, they've been held together by gravity and supported by the intense energy produced by nuclear fusion. In the extreme hot cores of stars, hydrogen can fuse together to manufacture helium. This process releases energy, and it supports the star from collapsing in on itself due to its own gravity. But after a while, a star ends up producing so much helium that the core itself is made of helium and it runs out of fuel. What happens then? Well, the star isn't getting the same energy output, so gravity starts to take over and the star starts to shrink. This increases the temperature just outside the core in the central region of the star, and it gets hot enough for hydrogen to start fusing into helium again just outside the core. This new energy influx expands the star once more, and it grows into a red giant star. And this continues for a long while, until the temperature rises and rises in the core and conditions are right for helium now to start fusing together to make the element carbon. Carbon is what we as humans are made of. For a low-mass star like our own sun, the core will eventually be made purely of carbon and a little bit of oxygen. The expanding star will get so big that the outer layers will kind of fly off into space, still heated by the very hot core. This is a spectacular display called a planetary nebula. Eventually, the outer layers get really far away, and the carbon-oxygen core starts to cool down. This leftover remnant of what was once a small star, we now call a white dwarf. But larger, more massive stars have more material and more energy, and they can start fusing together heavier and heavier elements past carbon and oxygen on the periodic table. The star goes through an ongoing cycle of expanding and shrinking with each new fuel source that can start to fuse. It produces plenty of neon and oxygen and silicon that ends up in the outer layers of the star, not just in the core. This process continues until you hit the element iron. Iron is the signal of death to a high-mass star. When producing iron, the nuclear fusion reaction no longer gives off the energy to support the star against gravitational collapse. Like pulling a chair out from underneath somebody, the star rapidly falls in on itself, and subsequently undergoes what is called a supernova explosion. This is an intense boom that can be seen far, far away. And conditions are so hot and dense and particles are colliding with one another that many more elements can be produced that we find on the periodic table. Throughout this explosion, these elements are dispersed back into the galaxy to literally become a part of future generations of stars and planets. So, if you ever feel like you're not very special, just remember that you are the culmination of more than 9 billion years of ancient suns working to forge elements in the furnaces of their cores. And you are a living testament to a history otherwise forgotten in a vast and unending cosmos. In the words of Carl Sagan, if you wish to make an apple pie from scratch, you must first invent the universe.